Hello folks, welcome to another digital SAT math test prep video presented to you by SX Math Help LLC. We are the math tutors in Montclair, New Jersey area. We have presented our contact information here in case if you have any questions, feedback, comments, please feel free to reach out to us and let us know. And today's topic that we would cover is another algebra topic, which is systems of equations in two variables. All right, two variables. So that's a topic that we will cover today. So without further ado, let's look into what is in store for this topic. So it is systems of equations in two variables, right? So as a reminder folks, we have seen linear equations in one variable in the past lecture, which will look like x plus 3 is, let us say, 10. And we have also seen linear equations in two variables, which would look like, let's say, x plus 5y is 50. So this is a linear equation in one variable because the equation has only one variable, which is x. This is a linear equation in two variables, x and y. Okay. Today we are going to have systems of equations. Systems of equations means more than one equation. All right. So in this case, I may have equations like, let's say, x plus 2y is 10, x minus y is, let's say, 8. So we have two variables, x and y, and we have systems of equations. This is equation 1, this is equation 2. Okay, so these are systems of equations in two variables. It means you have more than one equation and more than one variable. All right. So how do we solve this? So there are a few ways that you can solve such problems, right? So let's talk about that before we start doing today's problems. The first one is called the substitution method. Substitution method. Okay. What substitution method says is, let us consider this example. 3x is let's say 9, x plus, 3x plus 4y is, let us say, 7. Okay, these are arbitrary numbers I'm choosing right now. You don't have to solve this, but the idea is you can simply take the value of this 3x, which is 9, and then plug it in here in this equation for 3x. So it becomes 9 plus 4y is 7. So end of the day, you are left with only one equation with one unknown variable, which is y, and you can solve for y. So that's substitution method. So substitution method says that you take the value of an expression and from one equation and merely substitute that expression in the other equation, in the second equation. Okay, and then your equation will be left with one equation, one unknown variable, and you can solve for that. All right, by moving things around. All right, so let's see what are the other methods that we have to solve the systems of equations in two variables. Okay, there's something called elimination method. All right, elimination method. What this says is, let's say, consider this example, x plus y is 10, x minus y is, let's say, 8. Okay, here you can still do substitution. You can find x from the equation 1. Let's call this equation 1. Let's call this equation 2. You can still do substitution method. You can find x from equation 1, which is 10 minus y, and you can plug in the value of x as 10 minus y in this equation here. That's one way of doing it, right? That's substitution method that we saw in the earlier slide. You could also do elimination method. What it means is, clearly when you add these two equations up, clearly y gets eliminated. So y and minus y gets cancelled out. You're only left with x plus x, 2x is 10 plus 8, 18. See, clearly you are eliminating one variable, leaving only one other variable in the equation, and you can solve for that. All right, so this is elimination method. So once you find x, you can use either of these two equations to find the value of y. All right. Okay, so that is elimination method. The third method is graphical method. See, now that graphical method. Okay, so let's say x plus y is 10, x minus y is, let's say, 8. I think that was a previous example, a hypothetical example. So essentially you can bring both the equations in terms of y. Y is 10 minus x from equation 1, y is x minus 8 from equation 2, from this equation 2. If I rearrange the variables here, y is 10 minus x from equation 1 and y is x minus 8 from equation 2. Once I do these things, I can key in this information into the calculator, right? Or rather a graphing calculator. If you have a graphing calculator, you can key in this information, these two systems of equations, into the graphing calculator, and it is going to present a graph like this, something like, excuse me, this is a line, I should not make it curvy. These are linear equations whose graph is a line. Give me a second, okay. So again, this is a hypothetical example. I don't know how the graph is going to look like for these two systems of equations, but assume that this is going to look like this. So this would be the solution to this equation. This x comma y coordinate pair is the solution to this equation. So the graph can also come in handy. The graphing calculator can come in handy to solve systems of equations, okay. And the other way that you can solve systems of equations is, it's not a, yes, it is a way. So you can use matrices, but again, matrices are beyond the scope of the SAT test, okay. Matrices, and there's something called inverse of a matrix. Inverse of a matrix, we can use the inverse of a matrix to solve the systems of equations. Again, this is beyond the scope of the SAT test, so we are not going to cover this technique in this lecture, all right. So the worst case, if we are not comfortable with any of these, right, the substitution method, elimination method, graphical method, whatever method that we discussed, right, generally if it is a multiple choice question, MCQ, multiple choice question, and if the question says x plus y is 10, x minus y is 6, and if they ask you to solve for x and y, or in other words, if they ask you to find the values of x and y, what you can essentially do is, if it's a multiple choice question, they're going to have something like x is 8, y is 2, x is 6, y is negative 2, something like that, right. You can merely take the values and substitute in these equations to see which equation balances properly, okay. In case if you're not comfortable, I don't encourage you to do this method, because it's a bit time consuming, because you have to take all the four answer choices and plug into each of these two equations, right. That's going to take time. But worst case, let us say if you don't know how to solve this, and if you left with ample time before the test finishes, SAT test finishes, you can take the answer and then plug into these equations and see if they hold good, okay. And if they hold good, if this hold good, let's say this would be the answer, all right. But again, I strongly discourage you from doing following step 5 unless you are not familiar with other steps, other techniques that we discussed. All right. So without further ado, let's take a deep dive into today's problems. And again, folks, a reminder, whenever you see the problems, I strongly encourage you to pause the video and then try to solve these problems by yourself first, right, before continuing to watch the video. By this way, you get hands-on practice, and they say practice makes it perfect, all right. And you can always come back to verify whether you got the same answers as mine, all right. Sometimes I make mistakes too, so if you think I made a mistake, please feel free to reach out to me. I will be happy to post errata or corrections, right. All right, folks, the first problem here is asking us to find the values of x and y given two equations. Again, these are systems of equations, because I have two equations, this is equation 1, this is equation 2, and I have two variables in each equation, x and y. So these are again typical case of systems of equations in two variables. It's a systems of equation in two variables problem, okay. So if that is the case, we have to recall the techniques, the substitution method, elimination method, graphical method, all those things should come to your mind, okay. Those are the techniques that are used to solve this problem, right, okay. So in this case, clearly, let me read this question. X plus y is equal to 10, that's the first equation. 5 times of x plus y plus x is 100. Oh, clearly this is a case of substitution. Why? X plus 5 has a value of 10. I can merely plug in x plus y as 10 into the second equation, you see. Okay, let's do that. So the second equation is 5 times of x plus y plus x is 100, right. Now x plus 5 is 10. This is 10 from this is 10. This is 10 from this equation 1. Okay, so I'm going to plug that value in. So 5 times 10 plus x is 100. Okay, in other words, 5 times 10 is 50 plus x is 100. In order to find x, let me remove 50 from both sides. 50 and negative 50 gets cancelled out. I'm left with x on the left side, and on the right side I have 100 minus 50, which is 50. So the value of x here is 50. Okay, once I find x, I can go to any of these two equations, 1 or 2, and plug in the value of x there to find y. Alright, the choice is yours. Okay, let's do that. Let's pick equation 1. It seems to be very simple. X plus y is 10, because other one has some parenthesis, expression and all those things. Let's use equation 1. Alright, so from equation 1, 1 implies, that means equation 1 states x plus y is 10. We know x, we just determined x as 50, we just have to plug in x as 50 here. Alright, so x is 50 plus y is 10. So remove 50 from both sides to find out the value of y, but which leaves y is equal to 10 minus 50, which is negative 40. Okay, that's the answer. So x is 50, and y is negative 40. Sometimes the answer choice in SAT may be looking somewhat similar to this, 50 comma negative 40. So they may have given the coordinate pair, the values in the coordinate pair in x comma y format. So you still have to choose this. Though x is 50 and y is negative 40, the answer format is slightly different in SAT answer choices. In the multiple choice questions, this is still a valid choice, valid response. Alright, so that's okay. In case if you have time, I strongly encourage you to check your answers too, right? How do you check the answers? I don't know whether you'll have enough time in the SAT test, but if you do, I would say just plug in the values. See, you got x as 50, y as negative 40, right? Just plug it in the equation 2, let's say. Equation 2 has 5 times of x plus y plus x is 100. Let's see if we get 100 by plugging in these values, which is equal to 5 times of x plus y. X is 50, y is negative 40. When you add them up, you get 10 plus x is 50. So 5 times 10 is 50, and I have add another 50 here, so which is 100, which is exactly what you have here. So your values of x equals 50 and y equal to negative 40 is correct. Okay, and again I encourage you to back substitute the values of x and y into the original equation to see if they balance, and that's how the only way that you can check if your work is correct or wrong. But again, I leave it to you, because I don't know whether you have enough time to do these things, but that's what it is. Alright, so let's move on. Okay, so let's see what this problem is asking us to do. Find the values of x and y given that x minus 5y is 10 and 5y is 20. So clearly take up pause this video and figure this problem by yourself, and I am going to go for substitution again. Why? 5y is 20. This is okay. I'm going to call this equation 1 and 2 for the moment. Okay, so I can refer this back by equations 1 and 2. I don't have to read these equations again. Okay, clearly it is a question of substitution problem. Why? Clearly 5y is here and I have 5y here. I can take the value of 5y, which is 20, and plug it in here in this 5y. So it is a substitution problem again, right? This is a substitution problem again. Okay, so take the value of 5y from equation 2, which is 20, and plug it into 5y in equation 1. So we have x minus 5y is 10 and x minus 5y is 20 from equation 2. So I'm going to just substitute 5y as 20 as 10 to find x. Just separate x out from the rest of the terms. So I have to add 20 on both sides. This gets cancelled out. I'm left with x equal to 10 plus 20, which is 30. Alright. Now I can pick I cannot pick any equation 1 or 2 to find y, because why? The equation 2 here does not have the x term. You see, we found x, but it does not have the x term. So I am mandated to use equation 1, which has the x term, in order to find y. Let's do that. So equation 1 says from above x minus 5y is 10. Alright. So now we've just found out the value of x as 30. We are just plugging in the value of 30 here. Alright. 30 minus 5y is 10. Again, we have to isolate y if we are trying to find y. So let's do that. Let's remove 30 from both sides. This gets cancelled out. I'm left with negative 5y is 10 minus 30, which is negative 20. Alright. So I'm left with negative 5y is negative 20. I'm trying to find y. So divide both sides by negative 5. So negative 5 gets cancelled out. Let me do this way. We are left with y is equal to negative 20 over negative 5, which is 4. Okay, so x is 30, y is 4. The answer choice in SAT test may also look like 30 comma 4. That means x is 30, y x comma y, x is 30, y is 4. This is still a valid answer. All right. So now that we have time, let's do a quick cross check to see whether our values of x as 30 and y as 4 is correct or wrong by doing a cross check. All right. So let's do this. I'm going to use this place here. I'm going to say check. Okay. I'm going to check my answer. So let's do this again. Let's take equation 1, x minus 5y. Let's see if we get 10. Okay, we determined that x as 30. We determined x as 30 and y as 4. X is 30 minus 5 times y is 4. So x is 30 minus 5 fours are 20, which is 10, which is precisely what you have here. So our values of x and y, which is 30 and 4, are correct. All right. Okay, folks, let's move on to the next problem. I hope you got this problem. Okay, so let's read this problem. Find the values of x and y given that x minus y is 10 and 2x minus 5y is 50. So again, folks, the first step I'm going to do is to mark these as equations 1 and 2 so that I can refer them back. Okay, so then I have systems of equations, which means I have two equations and two unknowns, x and y. So these are systems of equations in two variables or two unknowns. Again, the light bulb should go off about the techniques that you can use to solve these such kinds of problems, right? Which is substitution method, elimination method, etc. Okay, here I can use substitution method. I can find x from equation 1 and put it into equation 2, but it's going to make my life a little complicated. All right, let's see how I'm solving this problem. I'm going to solve this problem using elimination method. That's going to be a little straightforward and easier than the substitution method as far as this problem goes. Okay, so from equation 1 I have x minus y is 10. You see the coefficient. When I say coefficient, when I say coefficient, I'm talking about the number sticking before the variable. In this case, let's say 5 is a coefficient of the expression 5x. In this case, negative 3 is a coefficient of the expression negative 3x. Okay, that's what I mean by coefficient. So let's remove this. That was an example. Let's go back here. Okay, so in this case, you see the coefficient of x is 1. The coefficient of x is 1 in this equation. Coefficient of y is negative 1. But in equation 2, the coefficient of x is 2 and the coefficient of y is negative 5, excuse me. Right? So none of the coefficient matches. The x coefficient is 1 and x coefficient is 2 here. The y's coefficient is negative 1, the y's coefficient is negative 5. The idea of elimination is to bring the coefficients of either x or y to be the same. Alright. Once you make the coefficient the same, then you can perform some operation like addition, subtraction to do the elimination. So in this case, I'm going to pick the choice is yours. I'm going to pick x variable's coefficient to be the same. Okay. In order for that to happen, from this equation, which is 1, this is first equation. I just rewrote the first equation. I'm going to multiply the equation throughout by 2. I'm going to multiply the equation throughout by 2. So I have x minus y. I'm going to multiply with 2. If I do something on the left side, I'm going to do the same thing on the right side. So like that. Okay, so I'm just taking equation 1 and multiplying everything by 2 in order to make the coefficient of x in equation 1 to look like the coefficient of x in equation 2. Alright, so let's do this. So this is a distributive property that has to be used. So which means that you have to take the number from outside and multiply with each number inside the parenthesis inside. Right? Let's do that. So it's 2 times x is 2x minus, I have minus here, 2 times y is 2y. So 2x minus 2y is 20. 2 times 10 is 20. I'm going to, for a moment, I'm going to call this equation 3. Okay, so equation 2 has it as from here. Equation 2 is, this is 2, as it has 2x minus 5y is 50. And equation 3, which is a modified version of equation 1, has it as 2x minus 2y is 20. All right, excuse me here for a second, let me write this as y, not, it shouldn't look like x. 2x minus 5y. Oh, let me rewrite this, 2x minus 5y. Okay, now it looks better. All right, this is equation 2, this is equation 3, all right, which is nothing but the modified form of equation 1. So now the idea is I made the coefficient of x to be the same, which is 2, 2. Now I can just subtract one equation from the other. If I subtract equation 3 from 2, let's see what happens. I'm subtracting the respective terms of equation 3 from equation 2. So we have 2x minus 2x, this gets cancelled out, which is 0, 2x minus 2x is 0. Next we are left with negative 5y, negative 2y, pay attention here, negative 5y, negative 2y, that is what, negative 5y plus 2y, negative 5y plus 2y, negative 5 plus 2 is negative 3 times y, all right. So this is negative 3y. Let's get rid of this, and we are left with 50 minus 20. So 50 minus 20 is 30. All right. So this is what we have so far. Okay. So if negative 3y is 30, 0 minus negative 3y is 30. If I want to find y, divide both sides by negative 3 to get rid of the coefficient of y on the left side. I am left with y is equal to negative 10. That's the value of y in this equation. All right. So now let's find the value of x. Again, you can take the value of y here and plug it into any of these two equations to find the value of x. So let's pick equation 1. Okay, equation 1 has it as x minus y is 10, and we just determined y as negative 10. So it's x minus y is negative 10 is 10. All right. So which means x plus 10 is 10. To find x, get rid of 10 from the left side. So we're left with x is equal to 10 minus 10, which is 0. So x value is 0 as far as this problem goes. X is 0, y is negative 10. You can always go back. Take these values and substitute into other equation and find out whether that equation holds. If it does, then you did a good job. All right. So x is 0, y is negative 10 is the answer to this problem. Again, we used the elimination method here. We could have used substitution, but it would have been a bit more time consuming, I would say, right? Okay, let's move on to the next problem, folks. Find the values of x and y given that 3x minus 2y is 12, 4x plus 5y is 39. Okay, again, it is not a handy ready case of substitution, so I'm going to use elimination method here. Okay, elimination method here. Again, with the elimination, I have to make the coefficient of either the y term or the y term or the x term to be the same. Here none of the coefficient matches. X coefficient is 3 and 4, they don't match. Y coefficient is, excuse me, the y's coefficient is negative 2 and 5, they don't match. So I have to make one of these coefficients in one equation to be the same as that of the coefficient in other variable in the other equation. So let's do that. So let's pick y this time. Okay, so this I'm going to call this as equation 1, I'm going to call this equation 2. Okay, I'm going to, y's coefficient in equation 1 is negative 2, y's coefficient in equation 2 is 5. Okay, let's make this look similar. So again, the least common multiple of 5 and 2 is 10, right? Least common multiple of 5 and 2 is 10. Why? What are the multiples of 2? 2, 4, 6, 8, 10, 12, 14 and so on and so forth. These are multiples of 2. What are the multiples of 5? 5, 10, 15, 20, 25 and so on, right? Okay, which number is common between these two sets? So clearly you have 2, 4, 6, 8, 10. I don't have 2, 4, 6, 8, 10 here. I have 5, 10, 15. I don't have 5, 10. Of course I have 10 here. 10 is the first multiple, the least common multiple that is encountered here. So the least common multiple of 2 and 5 is 10. So what I'm going to do here is I'm going to make both of these y expressions, y terms, to have a coefficient of 10. Alright, which means from 2 to 10 I have to multiply this equation by 5, and from 5 to 10 I have to multiply this equation by 2. Again, we are not talking about addition, subtraction, we are talking about multiplication here to make the coefficients uniform. Alright, so which means the first equation should be multiplied by 5, the second equation should be multiplied by 2 in order to make the coefficient of y term look like 10 or negative 10 or whatever it is. Alright, once we have that, depending on the sign, we can add or subtract to eliminate y. Okay, the reason for making the coefficients similar or the same between these two equations is to wipe out that variable y in this case. Let's do that. So we take let's take equation 1, multiply with 5. That's what we said here. Okay, let's do that. So we have 3x minus 2y is 12. I'm going to multiply whole thing with 5. 5 times of 3x minus 2y is 5 times of 12. When I do something on the left side, I have to do the same operation on the right side. So I'm multiplying both sides with 5, okay, in equation 1. So again, this is distributive property in effect. Take the number from outside and multiply with each number inside, each term inside. So we will get 5 times 3x, 15x, minus 5 times 2y is 10y. That's what I have on the left side. 5 times 12 is 60. Alright, I'm going to call this equation 3. This is nothing but the equation 3 is nothing but a modified form of equation 1. Alright, so I did my job here. So let's do the same thing here. So take equation 2 multiplied with 2. Okay, so take equation 2 and multiply with 2. What is equation 2? The equation 2 is here. 4x plus 5y is 39, right? Let's write this down. 4x plus 5y is 39. Okay, when I have to multiply with 2, that's 2 times of 4x plus 5y is 2 times of 39. I'm multiplying both sides by 2. So again, distributive property has to be applied here. Take the number from outside, multiply with each term inside in the parenthesis. So 2 times 4 is 8x plus 2 times 5y is 10y is 2 times 39 is 78. I'm going to call this equation 4. Okay, again equation 3 is nothing but modified form of equation 1. Equation 4 is modified form of equation 2. Why do I need to do that? I need to do that to make the coefficient, to make the coefficient of y look the same. You could also make the coefficient of x to be the same by multiplying both sides, by making it by determining its least common multiple and do the same path. But here I chose y and I'm trying to find the least common multiple of 2 and 5, which is 10. I'm trying to make the coefficient of y in both equations to be 10. Now I can simply add these two equations because 10y and negative 10y gets cancelled out, they get wiped out. I will be left with only an equation in x and I can solve for x. That's the idea. Alright, so let's do that. So I'm going to clear this out for a second. Now you know I took the least common multiple there. Least common multiple for x, 2 and 5 is 10. Alright. Okay. So now I have to, from third equation here, I'm going to copy this third and fourth equation there. Alright. Let's do that. The third equation is 15x minus 10y is 60. And the fourth equation is 8x plus 10y is 78. Okay. Simply add these two equations, add the respective variables in these two equations. 10y and negative 10y gets cancelled out, by the way. So I'm left with 15x plus 8x. So I'm left with 23x on the left side, and I'm left with 60 plus 78. I should have chosen some easier numbers. 60 plus 78, 7 and 6 is 13, 138. Okay, so let's see. In order to find x, so divide both sides by 23, the usual technique that we follow. X is, let's see what 23 times 6 is. These are 18, 12, 13. So I think x is 6 because 23 times 6 is 138. Okay, x is 6 in this problem. Once you find x, you can always plug in the value of x in any of these two equations and find y. Okay, let's do that. Okay, so let's pick one. One has it as 3x minus 2y is 12. By the way, you can pick 1, 2, 3 or 4, doesn't matter. I'm picking 1 here. So in this case, this is equation 1. This is the equation 1 as you see here. I just rewrote that here. Alright. So we just determined x as 6. X as 6 here. I'm just going to plug in the value of x as 6 here and find y. Alright. It's 3 times 6 minus 2 times y is 12. 3 times 6 is 18 minus 2y is 12. So let's remove 18 from both sides. Excuse me, it's not that clear here. Let me rewrite this. So in order to find y, let's isolate y. So let's remove 18 from both sides. This gets cancelled out. I'm left with negative 2y is 12 minus 18, which is negative 6. Okay, to find y, divide both sides by negative 2. So I'm left with y is equal to 3. Right, that's the answer for this problem. X is 6 and y is 3. All right, and again the answer choices may be given as 6 comma 3. That's a still legitimate answer. 6 comma 3. They're saying x is 3, x 6, y is 3 if they gave the answers in the coordinate pair. Okay, when I say they, I'm talking about the college board. All right, and again I strongly suggest, if you have time, go back and plug in the values of 6 and 3 for x and y into other equation and see if they balance. That's the way you can cross check your answer. Alright folks, this was a lengthy problem. Thanks for your patience here. I hope you understood the idea. Okay, so in this case, let's see, again this is systems of equations in two variables. And why? Because I have two equations, 1 and 2. If anything over one equation is a system of equations. And I have two variables here, x and y. So it's a systems of equations in two variables problem. Again, substitution method, elimination method, all those should come to your mind to solve the problem. Okay, clearly here, let me rewrite this. 2x plus y is 1, 2x plus 3y is 5. Those are the two equations given. So clearly I can, if I substitute one equation from the other, x term will get eliminated because luckily we have the same coefficient for x in both the equations, which is 2. Let's do that. So let me rewrite this. 1 has it as 2x plus y is 1, and this 2 has it as, equation 2 has it as 2x plus 3y is 5. Okay, I'm going to subtract equation 2 from 1. Okay, so let's do that. We are left with 2x minus 2x, that's 0. So it gets cancelled out. I'm left with y minus 3y. Again, y minus 3y, minus plus 3y. Y, I have it as y minus plus 3y. That is y minus 3y. Alright, minus and plus here is minus. Now, so the answer for that is negative 2y. Y minus 3y is negative 2y. On the left side is, I'm left with 1 minus 5, which is negative 4. Okay, 1 minus 5 is negative 4. Alright, so now to find y, just divide both sides by negative 2. This gets cancelled. So you're left with y is negative 4 over negative 2, which is 2. So value of y is 2 in this problem. Okay, again, once you have determined y, you can choose any of these equations 1 or 2 to substitute the value of y in order to determine the value of x. Alright, so let's pick one equation. Let's say 1 appears to be easy. Y is 1. We just determined y as 2, so just substitute y as 2 here. Alright, so it's 2x plus 2 is 1. We have to isolate x term here, so we have to get rid of 2 from the left side. So this is gone. On the left side I have 2x is equal to, on the right side I have 1 minus 2, which is negative 1. So again, to find x, divide both sides by 2. This gets wiped out. So x is equal to negative 1/2. That's the answer. So we have x is negative 1 half, y as 2. That is the answer for this problem. If you have time, I strongly encourage that you go back and substitute the values of x and y into the other equation and then see if they balance. If they balance, your answer of x and y are correct. All right. Okay. I just want to I would just want to say that there may be another flavor of the answer choices. I just thought about it. So let's do that, right? So in this problem, we got x as negative half and y as 2. All right. So these are the two lines. So each of the equation in the systems of equations is a line, is representing a line. Okay, it's a linear equation by themselves. Each equation is a linear equation by themselves. So it represents a line. So the answer, one of the answer choices, the SAT generally gives 4 answer choices unless you have to put in the answer choice. Okay, they may give a graph like this. X is negative half. Let's say this is negative half, and y is 2 here. Okay, you may have a line something. Let's see. So this one has. Okay. Something like that. So the okay, I'm assuming that one has positive slope, one has negative slope, but the idea is SAT may give 4 answer choices like this. All right. So in this case, now that you have determined, or something like this, right? So the idea is you have to choose this as the answer. Why? This is the one that has x as negative half and y as 2. So the point is SAT can add a slight twist to the answer choices, and rather than giving you direct answer choices like x equal to negative half and y equal to 2, or giving answer choices negative half comma 2, both are valid. This is valid, this is valid, this is valid as well. All right. They may give an answer in a graphical format. Okay, in this case you have to just go choose x as negative half, y as 2, and you have to choose whichever graph has this point. This point represents negative half comma 2. You have to choose that as the answer. All right, folks. It was a lengthy video, I know, so it ran over 30 minutes. That was not my intent, but at least I hope you learned something out of this video, and we were able to brush up your knowledge on the systems of equations in 2 variables. All right, keep practicing. These are not easy problems, but once you practice, you can get there. Okay, so thank you for listening, and I hope to see you in another lecture quite soon. All right, take care.